I welcome you all for my mathematics class. I go ahead with my Fourier transform problems. Today I am using the Parseval's identity to evaluate this integral. I have already proved the Parseval's identity and also the convolution theorem in my lecture 5. Please go through that. Now I will teach you how the Parseval's identity can be employed to get certain results or get the integration of certain integrals. So this is the integral which may be difficult for us to get. In fact, we can solve and get. But here what I am going to do is, I am going to apply the Parseval's identity and also the idea of Fourier transforms and then get the value of this integral. Now, you see that I will first of all write what is the Parseval's identity is. The Parseval's identity is, your Parseval identity is this, that is integral of 0 to infinity f of x modulus of that square is equal to 0 to infinity f of s modulus of that, this one. Here you see that the f of s is nothing but the Fourier transform of this f of x, and that here I'll assume that I will take, let f of x be equal to your e to the power of minus ax. A is greater than 0 and this is x is defined in, say it is belonging to 0 to infinity, like this. Let me take the function f of this. Then you see that this function, then the sine transform, Fourier sine transform, I will put it in that way, then the Fourier sine transform of f of x is equal to e to the power of minus ax is, what is that sine transform now? It is given by it is integral of, I will write this, integral of 0 to infinity, it is f of x into sine sx dx. This is equal to, it is nothing but, it is 2 by pi. Actually, I will write like this instead of like this. I will put it in this form, s of f of x. This is how I must write. So this is equal to 2 by pi into integral of 0 to infinity e to the power of minus ax into sine sx into dx. So this is the definition of a Fourier sine transform, and you see that this is a well-known integral. This is a well-known integral. Immediately you can apply the the integral value of this. So what is that equal to? So this is nothing but 2 by pi into, you see that the integral value of this is e to the power of minus x divided by a squared plus s squared into, within brackets, it is minus a into sine ss, see, minus a into sine sx minus s cos sx. So this is the integral. This is the integral of this. This is the value of this integral. So this is 0 to infinity. So I have integrated. So this integral is a well-known one, for which the answer is minus a sine sx plus minus s cos sx, and the limit is from 0 to infinity. So this is equal to, you see that this is equal to 2 by pi square root of that within brackets. If you apply, now you have to apply the first limit infinity wherever x comes, minus apply the limit 0 to x wherever x comes. You see that when you apply this infinity, e to the power of minus infinity is 0. E to the power of minus infinity is 0. So if you apply the first limit, it is e to the power of minus infinity is 0. 0 is into anything is 0. So give it up, don't worry about that. So this is 0 minus, open a bracket, put x is equal to 0, it is 1. So 1 divided by a squared plus a squared. I will put it like this. Open a simple bracket. Now in the place of x you put 0. So sine 0 is 0. Cos 0 is 1. So it is minus s. So this is what you get. So this is equal to, this is 2 by pi square root of this. You see that minus into minus is plus. So this is divided by a squared plus s squared. So you see that I am able to get the Fourier sine transform of f of x. F of x, namely e to the power of minus ex, as this. So I have got this f of x. Now we have, say I'll write here. Now we have f of x is equal to e to the power of minus ax. And what is the cosine transform of this? So you see that here this is the Parseval's identity is in general. And if you want the Parseval's identity for the cosine transform, you see that here this f of x will be the given function, f of s will be the Fourier sine transform of f of x. Understand that. That means what? Here this f of x is given to you and whose sine transform is here. Even if you want, you can use the Parseval identity for the cosine transform and also for sine transform in the same way. That is, in this place of f of s, it is nothing but the cosine transform, and if it is the sine, it is a sine transform. That is the only difference. Now you see that, therefore here I will write this SF of f of x is equal to, it is nothing but what we have got 2 by pi square root of this into s divided by s squared plus a squared. So we have got these two. Now you see that having got the value of f of x, we have fixed the value of f of x e to the power of minus ax. Now we have found the sine transform of this. Now you substitute, we will take this as 1. Now you see that this is 1 and this f of s is equal to f s of f of x. So this f of s is nothing but this. Now let me substitute in 1. So I'll rub off this. So what is that you get now? Substituting in 1, say you call this as 2. Call this as your 2. Substitute 2 in 1. In 1. So what is that you will get here? It is 0 to infinity, it is e to the power of minus ax whole squared into dx is equal to, it is actually modulus, but when you square it is nothing but your this one. See, it is a modulus whole square like this. Okay, and here it is, what is that you get here now? This is nothing but your, it is 0 to infinity, it is f of s is 2 by pi square root of that into s divided by s square plus whole square into ds. So this is, I make only the substitution in this place. So what is that you get here now? That is 0 to, I'll write this here, 0 to infinity, take this 2 by pi square root of square of this 2 by pi, square root of that was simply 2 by pi, and this is s squared divided by s squared plus a squared into ds. It is nothing but 0 to infinity e to the power of minus 2ax into dx. So this is going to be, we are going to e to the power of minus ax into e to the power of minus ax, it is e to the power of minus 2ax, and this actually, this is a modulus of that. Now you see that what is that you get here now? So this is equal to, now you see that this is modulus of that. Yeah, got it. Yes. Now what is that you get here now? This is, so this is equal to, what is the integral into this thing? You can just leave it like this because this is a positive quantity, 0 to infinity, you can leave it. So you see that this is nothing but e to the power of minus 2ax divided by 2a, and this is 0 to infinity. So as I told you this, if you put z infinity, it is 0 because e to the power of minus infinity is 0, minus, if you apply the second limit, it will be 1 by 2a. 1 by 2a. So this implies 0 to infinity s squared divided by s squared plus a squared into ds. Bring this to the other side, it is pi by 2 into 1 by 2a, that is equal to 5 by 4a. So this is the value of this integral, and you must know that we want the integral of this, namely 0 to infinity x squared by a squared plus x squared whole squared dx. But here you see that the variables are different. Here this is true for, this is not only for s, this is true. This is true for any variables, it's an arbitrary variable. So you can very well write, therefore we can write, therefore, so you can engineer, therefore, since s is arbitrary, that is, this is true for all, this integral is, this is true, let me call this as your 3. This 3 is true for all values of s. So since s is arbitrary, we get, what is that you get? In general we get 0 to infinity of x squared by s squared, this is x squared, is x squared plus a squared, this one, this is whole squared, this is whole squared, s squared plus a squared whole squared into dx is equal to pi by 4a. So I am getting the result. So this is how we do this problem, and here you must know that here this Parseval's identity, by chance, suppose you can very well, I will just give you a hint. By chance, if you are asked to evaluate 0 to infinity without this x squared, then I will give you this as your work which you can practice at home. That is, try to solve this problem by yourself. If you are asked to find the integral value of this 0 to infinity without this x squared, that is, without this x squared means dx by a squared plus x squared whole squared, in which case you consider, instead of the Fourier sine transform, here we have taken Fourier sine transform, you take Fourier cosine transform. What is that? You take Fourier cosine transform for the same function f of x is equal to e to the power of minus ax. For this, if you take Fourier cosine transform, then you will be in a position to get the value of the integral, namely 0 to infinity. This x squared will not be here, 1 by a squared plus x squared whole squared into dx, using Parseval's identity. Okay, so this is a reasonably a good problem that normally they ask in university examination. Okay, now let me go for the next one. I will teach you one more problem in this. Here you see that you are asked to find the Fourier transform. See, find, here I will write here, find Fourier cosine transform of x to the power of n minus 1 and fs of n minus 1. You are asked to find the value of these two functions. See, I will write here, we know that the 0 to infinity, I will write here 0 to infinity e to the power of minus x to the power of n minus 1 dx is equal to gamma of n. This is a gamma function, gamma of n. This is a very important integral. This is a gamma integral, and you see that this is a factorial integral, gamma of n, and in fact gamma of n plus 1 is gamma of n plus 1 is factorial n. So this is a factorial integral. Gamma of n is given like this. Using this particular idea, we will try to solve this. See, we will try to get the value of this. Now, I'll write here. Now, 0 to infinity, I will write here x to the power of n minus 1 into e to the power of I will write, take this minus isx into dx. See, here I will take this as, this is what I get. Now, what I will do is, consider, I will write like this, consider the integral. Consider the integral 0 to infinity x to the power of n minus 1 e to the power of isx dx. Now let is x be equal to your t. What is that I take? I let isx be equal to your t. So this implies x is equal to t by is and dx is equal to dt by is, and t tends to 0 when x tends to 0. T tends to 0 when x tends to 0. T tends to plus infinity when x tends to plus infinity. So you see that in both the cases the limit of the integral will not change. Therefore 0 to infinity of x to the power of n minus 1 e to the power of isx dx is equal to. So you see that this is, and another thing is, so what is your x to the power of n minus 1? It is t to the power of n minus 1 divided by is to the power of n minus 1. So here I will write this as 0 to infinity, x to the power of n minus 1 is 2t to the power of n minus 1 into, it is e to the power of, here it is minus t, it is e to the power of minus t into dt, t to the power of n minus 1 divided by is to the power of n minus 1 divided by is. So this can be written as, so I will write this as 1 by n minus 1 plus 1 is is whole to the power of n. It is 0 to infinity e to the power of minus t, t to the power of n minus 1 and dt. Now you see that, compare this with 1. So call this as your 1. So you see that this is same as your 1. See this integral? This is same as your 1. Therefore you can write this as, see it is gamma of n divided by is whole to the power of n. So this is what you get. See, this is x to the power of n minus 1. So this is gamma of n, because this is same as this except for that variable. So it is is to the power of n. So you can write this as, see it is gamma of n divided by s to the power of n 1 by I whole to the power of n. So this is equal to, so this is gamma of n s to the power of n, multiply it by I and divide it by I. So you will get this. So this is equal to gamma of n divided by s to the power of n into, you see that I squared is minus 1. So minus I whole to the power of n. So this is nothing but gamma of n divided by s to the power of n. It is minus I whole to the power of n. So this is what I get. So you see that still more I will do here. That is this is equal to gamma of n s to the power of n. So this one can be written as cos pi by 2 minus I sine pi by 2 whole to the power of n. I, in the place of I minus I can write cos pi by 2 minus I sine pi by 2, because cos pi by 2 is 0, sine pi by 2 is 1, 1 into minus I is minus I. So in this place I can write. Now using De Moivre's theorem, so this is nothing but, it is your gamma of n divided by s to the power of n factorial, and this is e to the power of minus I pi by 2 whole to the power of n. That is equal to what? It is gamma of n s to the power of n e to the power of minus I n pi by 2. So this can be, I can write one more step as this. This is equal to gamma of n divided by s to the power of n. It is cos n pi by 2 minus I sine n pi by 2. So you call this as your 2. So I am able to get the value of this x to the power of n minus 1 e to the power of minus sx into dx as this. Now you see that I will start. So let me write again. So this is the result that I have got here. I'll rub off this. Now I'll write. See, now what is this? This is nothing but x0 to infinity of x to the power of n minus 1 e to the power of isx minus of this dx can be written as, this is nothing but what? It is 0 to infinity x to the power of n minus 1 into, it is nothing but what? It is n minus 1, it is cos sx minus I sine sx into dx. So this is equal to, this is nothing but, it is 0 to infinity x to the power of n minus 1 into cos sx into dx minus I 0 to infinity, and it is x to the power of n minus 1 sine sx into dx. So this is what I have here. So we call this as your 3. So you see that this is what I get. Now you see that when you multiply this by, so when you, now what is my, now I'll write here. So I have got this third result. This is also equal to this, and the very same integral also equal to this. Now I'll write here, see, now you see that your f, see, you see that your see 2 by pi. Now see, you can multiply this by 2 by pi on both sides. 2 by pi of this, it is 0 to infinity. So you see that you get yes. So you see that here we will make first, you see that compare these two. So from 2 and 3 I will write here, from 2 and 3, that is equate real and imaginary parts. Equate real and imaginary parts. So what is that you will get here? It is 0 to infinity x to the power of n minus 1 cos sx dx is equal to, now what is the real part here? It is gamma of n divided by s to the power of n into, see, gamma of n, into cos n pi by 2. So this is equating the real part, and if you equate this one, therefore multiply this by 2 by pi. So therefore square root of 2 by pi into 0 to infinity x to the power of n minus 1 cos sx dx will be equal to 2 by pi into, what is that? You get this to be gamma of n divided by n s to the power of n into cos n pi by 2. So you see that this is nothing but, that is this is nothing but your Fourier cosine transform for fc of x to the power of n minus 1 is equal to 2 by pi square root of that factorial, gamma of n divided by s to the power of n into cos n pi by 2. Okay, now and if you equate the imaginary parts, what is that you will get? 0 to infinity x to the power of n minus 1 sine sx dx is again equal to what? Gamma of n divided by s to the power of n into sine n pi by 2. So this implies fs of x to the power of n minus 1 is equal to 2 by pi. See here, Just like that, you have to multiply this by 2 by pi. So 2 by pi, here you understand, then only you will get a hand in mathematics. So you understand that how I get this. So multiply this by 2 by pi, square root of that, then you will get fs of x to the power of n minus 1. So this is gamma of n divided by s to the power of n into sine n pi by 2. So you call this as your 4, like this, call this as your 4, call this as your 5. So what is that you get here? Therefore I am able to get, see, what are you asked to find? Fc of x to the power of n minus 1 and Fs of x to the power of n minus 1. Therefore we get, see, therefore Fc of x to the power of n minus 1 is equal to, it is 2 by pi into, it is gamma of n divided by s to the power of n into cos n pi by 2. Then Fs of, it is x to the power of n minus 1 is equal to, it is 2 by pi into gamma of n divided by s to the power of n, and it is sine n pi by 2. So these are the what. Now I'll just do a supplement part of it. Find, I'll write here, find f of square root 1 by 6. This is like this. Fc or whatever it is, Fc of Fs or whatever it is, whatever you get, you want, we will get. So you see that Fc of x to the power of n minus 1. So what is that? You will get x to the power of n minus 1. So here this is nothing but what? Here find this. That means what? This is your, that is f of 1 by square root of x is equal to f of x to the power of minus half. Now, so this is what I should do. See, to find Fc of square root of this, which is equal to Fc of this. Now we have, say, I'll write here, we have Fc of x to the power of n minus 1 is equal to 2 by pi into gamma of n divided by s to the power of n into cos n pi by 2. Now take n is equal to half. So if you take n is equal to half, it will be half minus 1 is this one. So take n is equal to half, then Fc of x to the power of n minus 1 is equal to Fc of x to the power of half minus 1, that is equal to Fc of x to the power of minus half, that is equal to your Fc of 1 by x to the power of half, that is equal to your Fc of 1 by square root of x. So this is what I want. Now you have to find. So wherever x comes, you have to substitute only half. So what is that you will get? Therefore, Fc of 1 by square root of x is equal to, so wherever x comes, so here it is 2 by pi into, this is gamma of half divided by s to the power of half, then this is cos n pi by, see, cos of n is equal to half into pi by 2. So this is equal to square root of 2 divided by square root of pi into gamma of half is square root of pi divided by s to the power of half into cos pi by 4, since gamma of half is equal to square root of pi. So this is equal to square root of 2 divided by square root of pi into square root of pi divided by square root of s into cos pi by 4 is 1 by root 2. So root 2, root 2, root pi. So this is equal to 1 by square root of s. So you see that there 1 by root of x is self-reciprocal. You can find that the Fourier cosine transform of 1 by root x is 1 by root of s. That means 1 by root of x and 1 by root of s are self-reciprocal. So what is that we get? So similarly you try to find this. There also sine n pi here also, if you put n is equal to half, it is going to be what? 1 by 4, pi by 4, sine pi by 4 is also equal to 1 by square root of 2. So therefore I will write here, therefore fc of 1 by root of x is equal to 1 by root of s, and therefore 1 by root x is self-reciprocal. So this is a very important problem. You take care of this, and this is how it must be done. This is a very important one, and if you are asked to find the 1 by root x using this, then you have to write this, substitute here again n is equal to half, you will get the result. We will do more problems in the coming days. Thank you.